Okay, in this video I'm going to do an example problem. It's really taken from the text, and I'm going to do the first 5 or 6 here out of a dozen or so in the textbook. It gives you, and the textbook does not give you enough information to solve the problem, by the way, and I'm giving you the slash numbers here. And that's going to allow us to solve the problem. The book doesn't give you the slash numbers, and so it's kind of hard to solve it without enough information. In any case, it gives you a network with a slash number, and it asks for the class of the network, the subnet mask, the number of subnets, and the number of IPs per subnet, and the number of hosts per subnet, which is just 2 less than the number of IPs per subnet. And the first thing we're going to do is look at the first number here in the IP address to determine the class. And you'll recall that starting with 0 we get class A, starting with 128s we get class B, starting with 192s we get class C's, and starting with 224s we get class D's and E's, which we don't use. In any case, these are special numbers: 0, 0 plus 128, 128 plus 64, and 64 plus 32 is 224. And so we can see immediately that the 128 is a class B network. The 135 falls in the range from 128 to 191, which is the class B's. 192 is up in the class C's. 211 is in the class C range. 10 is in the A's. And 32 is also in the A's. Okay? And each of these classes tells you what N is. Okay? The number of network bits. Okay? And N is 16 for the class B's, it's 24 for the class C's, and it's 8 for the class A's. But when you go to a slash 30, these slash numbers include both the network and the subnet bits. Okay, so if you have a subnet mask, it always starts with a whole bunch of ones. It always starts with a whole bunch of ones, and then it ends with a whole bunch of zeros. The number of ones is N plus S, and the number of zeros is H. Okay? And so given that N is, for the first one, N is 16, and N plus S is 30, that gives us that S is 14. Okay? Again, N is 16, N plus S is 30, therefore S is 14. And when N plus S is 30, there's only 2 more bits left over for H, and so H is 2, and so the number of IPs per sub is 4, and the number of hosts per sub is 2. Okay? And we're going to follow the same exact logic on all of them. For the next row down, N is 16, N plus S is 25, therefore S is 9, and H must be 7. 16 plus 9 plus 7 is 32. 2 to the 7th is 128. 128 minus 2 is 126. I didn't write out what 2 to the 9th was for space reasons here. For the third one, class C, N is 24, N plus S is 28, therefore S is 4. And H is also 4. For the next one down, it's a class C, so N is 24, N plus S is 26, therefore S is 2, and H is 6. And we can make these calculations. Finally, on the last 2 rows are both class A's with N equals 8. If N plus S is 13, then S is 5, and H is 19. And if N plus S is 20, where N was 8, then S is 12, and H is also 12. Let me think about that one for a minute here. Hold on. n plus s is 20, n is 8, therefore s is 12. And then from 20 on up to 32 is another 12. Yeah, that's right. And so 2 to the 12th is 4096, so 2 minus 2 less than that is 4094. Yep, you got to think about these things. Okay, so there's how to do that problem. I'll throw in this extra problem here. How is the network address of this with subnet mask of that written in CIDR notation? CIDR notation is this slash notation where the slash is n plus s. And the number of ones in the mask is n plus s. We get 8 ones in a 255, and we get 5 ones in a 248, so 8 plus 8 plus 5 is 21. Therefore, this is 36.0/21. Okay? Okay, hope that helps. This is just like your homework with some different numbers in it.